Hey everybody, this is Larry. This is day 15 of the Leetcode Day Challenge, and I guess there'll be a weekly one afterwards. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about today's farm. Today is a rest day for me, but I didn't sleep that well. I just kind of rested a lot and forced myself not to do anything, which is good, but I don't know, my eyes are still kind of tired. But the Yankees won, so go Yankees. 13 days to the marathon, so I am just 2 more hard workouts to go, and then we'll try to figure things out. I don't know. It's kind of crazy, isn't it? That I mean, I guess it reminds me a little bit of like college or high school. High school going to college or something like this, where you work so long for just like one event, you know. And I feel like I haven't done that in a long time because, you know, I'm an adult and I have an adult life, and these things, you know, they're more uncertain, right? There's no timeline, but in general, of course. But this, yeah, so it's kind of crazy that, you know, I've been training for 4 months, about 50 miles each, 60 miles peak. And yeah, and now we'll see how far that gets me. Still 2 weeks though, so I'll probably still talk about it a couple of times more. But let's take a look at today's farm. 2938 Subway black and white boars. Let's go. Let's separate our boars. There are M boars on the table. Each boar has a color black or white. You're given binary string 1 and 0 represent black and white boards respectively. In each step, you can choose 2 adjacent boards and swap them. Return the minimum number of steps to group all the numbers, the black boards to the right and all the white boards to the left. Okay. So the white ones are which one? I don't know why they say it in like 1 and 0 and black and white instead of 0 and 1 or something. I don't know. By the way, how would I solve this? I think the way to think about this is that there are a couple of ways to think about it, really. But the way that I would think about it, and there are, like I said, a couple of equivalent ways to think about it. But the way to think about these swaps is that, well, there are 2 things, right? One is that you'll never swap black boards with black boards or white boards with white boards, right? Like it like if you think about it, you don't have to, but if you think about it in terms of states or like, because they're not differentiable, they're not distinguishable. If you have like, you know, a configuration of boards and you swap 2 white boards, they're still the same configuration. So so you just never do it for minimum step reasons, right? That one should be obvious, but it's worth saying out loud because then now it allows you to make the second observation easier, right? So you're always going to only swap black boards and white boards, right? And then now you can make a further statement, which is that you will only swap them if the white board goes to the left, I think. Yeah. White board goes to the left and the black board goes to the right, right? So that means that you're only going to swap them if it's 1 0 into 0 1, right? Hopefully that kind of makes sense. And then now, once you think about that, right, and everything I said, I kind of go through it one step at a time. Once you think about that, then now you can go through it in a linear kind of way, because then now for every character. Do I have a longer string? No? Okay, fine. Let me just make a longer string. For every character, and let's say we're here, then now we can ask, how many swaps does this board have? Well, this board has as many swaps as, it feels like I'm saying a tongue twister, like, how many swallows can a swallow swallow if a swallow can swallow? Well, I don't know. Anyway. But how many boards can, or how many swaps does this board get involved with, right? And this board only gets involved with white boards to the right of it, trying to get to the left. So then another way of saying this is that for each one, you're trying to figure out how many zeros are to the right, because that's how many swaps you can factor out, right? And in this case, there's going to be 5. And you can also say the same for 0, right? You can say that for every 0, how many ones are there to the left, because then you swap. Of course, if you do it this way, then you double count, right? Because then now you're counting all the zeros and swapping to one. But you could as long as you're double counting consistently, it's fine as well, to be honest, because that means that you could just divide it by 2, right? But there's also very easy symmetry for this one to exploit, so that you don't have to do it. Which is that, of course, you just could take either you could because every swap includes one white ball and one black ball. It's equivalent whether you only take all the black balls or all the white balls for the swapping. So that's really the idea about it. So then now maybe I could have I don't know, all these whatever white balls and black balls. So let's just do 1 is equal to, we count all the zeros, right? And then now we can say total is equal to 0. If C is equal to 0, then now zeros to the left. Maybe I can make them more clear. To the right. We subtract 1. Else total we added to zeros to the right, right? And that's pretty much it. I mean, I know that this may. I feel like there are a couple of problems enough that you may kind of look at this and be like, oh yeah, of course I know this. Of course this is the way to do it. But okay, I mean, I think this is the moment where I realized that my camera is on the wrong browser for whatever reason. I mean, I think that I didn't really put that much on screen, so you know, the only thing that I was saying is that if I had, sorry friends, the only thing that I was saying is that if I had something like this, I mean, I think I said everything out loud anyway. The only thing that I was saying that if I had something like this, then and we're here, then we can just count the numbers of zeros to the right or black balls to the right or something. And the coding, I mean, you see it now. It's 6 lines of code. I actually got it right the first time mostly. So I don't think I actually click on. Oh no, I did click on submit. But so my apologies that you didn't get to see me type, but I think this one was pretty straightforward relatively. I guess I had 2 Leetcode windows open, which sometimes happens. So and the thing kind of locked into the wrong one, so my apologies. But hopefully, yeah, the explanation should be good enough. I didn't do too much visualization. I was just doing like zeros and ones and stuff like that. Yeah. I mean, as you can see, this is going to be linear time, linear time, constant space. This is linear time. This for loop is obviously linear time. And the idea here is that when you see a 0, well, you're going from left to right, so you know that that many amount of zeros. When you see a 0, then now it goes to the left, so then you count one fewer, and then you just sum it. And when you see a 1, in this case you see a 1, then you just count the number of zeros to the right, because that's the number of swaps that you'll see, right? So that's pretty much the idea. Like I said, like I said, it is something that you can easily memorize, just because for whatever reason Leetcode have asked this like 3 or 4 times in different ways. But try to understand why, and you know, I think this is a cool thing to kind of just go through every step of the way. That's all I have for this one. That's all I have for today. Presentation's a little bit messy, but hope y'all be able to get it. Thanks for watching. Stay good, stay healthy to your mental health. Go Yankees and go Liberties. And go Mets fine. I'll see y'all later and take care. Bye bye.